Section 10.4 is where we will talk about perimeters and areas of similar figures. So what will happen is we will use a scale factor of similar figures, such as A over B. And when that happens, you will be asked to either find the perimeter or the area. If you're doing the perimeter, the scale factor will be the same ratio as the perimeters, okay? But if I'm going to be doing the ratio of the areas, then I'll have to take that scale factor and square the top and the bottom number. So let's take a look at an example. So this first example says the figures below are similar, and then this kind of got cut off, but it's saying the label sides are corresponding. So it's asking me to find the perimeter of the larger square. So first thing I notice is that I have two side lengths. Well, that right there will be my scale factor. So what you can do is you can set up a proportion, putting the scale factor on the left side, and then just matching up the corresponding perimeter on the right side. So I did 2 to 5, so then on this side I have to go in that same order and go 8 to x, so that 2 and 8 show that they're on the same square. Then I'm just going to solve that proportion. So if you remember, we cross multiplied, so I did 2 times x, and I did 5 times 8, and I set up my equation, and then I'm going to solve by dividing by 2. So x would be 20. So my new perimeter then would be 20. Alright, pause the video and try the next one. So on the next question, you should be setting up your proportion as 9 over 4 equaling x over 12. Again, it's crucial that the 4 and 12 are on the same row because they're on the same triangle together. Then you should be cross multiplying and dividing. So I would cross multiply 9 and 12, multiply 4 and x, so I get 108 equals 4x, and then I'm going to divide by 4, so I end up getting my perimeter to be 27. Now let's see what happens when we use the areas. So on this question, it said the area of the smaller regular polygon is about 27.5. It says, what is the best approximation for the area of the larger regular polygon? So even though they didn't say what the scale factor is, I know the scale factor is here. It's 4 to 10. Now if you remember, when we were doing area, we have to square the scale factor. That's what this top theorem over here is saying. So when I set up my proportion, I am going to take my scale factor, 4 over 10, and I'm going to square that. And then I'm going to set it equal to my two areas. So the only difference between these problems is for the area you have to square it, for perimeter you're not. So I would do 4 squared over 10 squared equaling 27.5 over x. And again, notice that my 27.5 is matched up with the smaller pentagon. Then I'm going to go ahead and do my squares. So I got 16 and 100. Now I'm going to cross multiply. So I would get 16x and multiply 127.5 and get 2750. Now I'm going to divide by 16 and I get 171.875. Since it's asking for approximation, the answer was 172. Alright, you're going to pause the video and try the GOTA question. So in the GOTA question, it first gives me a scale factor of 3 over 4, and then keywords is it says it's giving me the area, which tells me I'm going to end up squaring these, and then it also gives me the area of the larger one, so that's going to be crucial, making sure I set it up on the correct proportion. So first thing was, I went ahead and squared the 3 and the 4, and then it said the area of the larger one, so 4 is bigger than 3, so that's why 96 needs to be on the bottom, matching up with 4. So once I have my proportion set up, then I would square those numbers, so I get 9 and 16. Now I'm going to cross multiply, so 9 times 96, 16 times x, and then divide by 16, so that's why your answer should be 54. So not too bad of a lesson. It's really just setting up the proportions correctly, and the biggest thing, making sure you remember for perimeter, I don't have to do anything extra, but with area, with my proportion, I do need to square that scale factor.